Hi, this is Sharan. In this video, we are going to see how to use Python in order to implement the clustering algorithm. In my previous video, which I'll be attaching on the top as well as will provide the link in the description, I have explained the concept behind the clustering algorithm, like what the clustering algorithm means and the step-by-step process involved in building the KMeans algorithm as well as the math behind it. So if you are interested in it, please check those videos before coming into this implementation. Let's go and start the implementation using Python. In order to implement the KMeans algorithm, we need to have three libraries. So in this case, I'm using NumPy as the input that I'm going to pass is a matrix. Second one is I'm using matplot library in order to plot the elbow curve as well as the scatter plot to see how our data is distributed. And the third is I'm using the sklearn in order to import the KMeans algorithm. So let's just import all these libraries. If in case you have issues in any of those libraries, or if you get an error message saying that those libraries are not available, you might have to do the pip install and ensure that these libraries are available. So next one is we are going to read the sample dataset. So here I am passing a simple array as an input. The first element of the array is weight. The second element is the height in centimeters. So this is just a random data set. You can come up with your own data set. So after reading this array, so before going through this particular code, I just want to execute and then get the output and explain you how the code works. So here in the plot, you can see that when we have 1, so this is the distortion value is very high. So what we do here is we do a simple for loop and we iterate through the number of clusters. So when we have one cluster for this particular data set, based on the centroid identified using the KMeans algorithm, we add up all the sum of squared errors between the data points as well as the centroid that it will be associated to. So if in case we have only one centroid or one cluster, which means that we will add up the sum of squared error of all these data points to that particular centroid. So generally, as I explained previously, the distortion would be quite high when we have just one cluster. So we can here see that when we increase the number of clusters to 2, there is a huge drop in the distortion. But after that, as we progress the number of clusters, it becomes more or less a straight line and there is no significant drop. So based on this plot, so here we identify that 2 is the ideal number as there is a huge drop, and after this point the drop is not significant and it's more or less flat, so which looks like an elbow here. So this clearly tells us that for this particular data set, the optimum number of clusters is 2. Okay, so now let's take 2 as the number of clusters for this data set. So before building the KMeans algorithm, let's just do a scatter plot and then see how our data is distributed. So we use the plot.scatter and then pass the weight as well as the height that is present in our data set, and we use the true positions. So this is the distribution of our data. So we are going to cluster them into 2 different groups. So we are going to use the KMeans algorithm. In order to execute the KMeans algorithm, we need to pass the number of clusters. So this is a mandatory input. In addition to the number of clusters, we are also passing the maths iteration and defining it as 100. So what it means is the KMeans algorithm will iterate until it converges with the final clusters. So here by defining it as 100, what we mean is before reaching 100, if the convergence happens, so then that's good. But if the convergence doesn't happen, then we stop at the maximum iteration, which is 100, and identify whatever clusters has been captured at this point as the final clusters for the data set. So let's just execute it. So we use the KMeans algorithm and then we fit it on our data set, which is the weight and height data set. We execute this. So now the KMeans algorithm has been built on our data set. So we can use the cluster centers in order to identify the centroids for our data set. So there should be 2 centroids since we are passing number of clusters as 2. Yeah. So here we can see that the centroid 1, which is the first cluster, is for 60.8 kilograms and height 154 centimeters. The center for the second cluster is 90 kilogram and 176.6 centimeters. So now based on these centroids, our data set would have been divided into two clusters depending upon the data element that is closest to the centroids, to one of these centroids. So we use KMeans.label to identify the groups to which our data set belongs to. The sequence here would be exactly same as the sequence that we have passed as an input. So now we can clearly see our data set is divided into two clusters. So 0 is 1, and then the second cluster is being identified as 1. So now what we do is we use the same scatter plot, but we pass the labels as an input to the scatter plot, and then we use a color scheme. We use the rainbow color scheme to differentiate the data set into two different clusters. Let's execute this and then see how our data set looks. Yeah. So here we can clearly see that the data set is divided into two different clusters. So one here as well as one here. We can also plot the centroids on top of the same chart and then see how the centroids are for these two different clusters. Okay, so here we can clearly see for this particular cluster the centroid is here, and this second cluster the centroid is located here. So what we do here is we just pass on the centroid location, the first as well as the second cluster, and we identify them by color coding them into black. So that's about the K-means algorithm and doing the simple plot. So if you want to learn more about the clustering algorithm, or if you want to build the K-means algorithm on a different data set, I have identified the mall customer segmentation. So this is one of the free data set that is available in Title, where for all the customers we have the age, annual income as well as the spending store. What you can do is you can take maybe two attributes at a time, maybe the age and the spending store, or annual income and spending store, and then see how the clusters are coming up. And finally you can also pass all the three inputs. So it would that the data set would have 3 dimensions. So all the 3 dimensions to the clustering algorithm, and then see how the clusters are coming up. So that is one of the exercise for you to try by yourself. That's it about the simple K-means algorithm. Coming to the advantages and disadvantages of K-means algorithm. The advantages are it is very simple to implement and warm start. Unlike recommendation engines such as collaborative filtering, K-means algorithm doesn't require a large amount of data set to start, and it can be easily adapted to many scenarios. So we can use a K-means algorithm for a range of scenarios such as clustering all the different sets of documents, clustering the images. It can be used for customer segmentation. So it can be used for any scenario where we want to group the data sets into multiple clusters. Coming to the disadvantages. So here one of the major disadvantage here is the value of K is being manually computed or manually identified. So when the user goes wrong in identifying the value for K, pretty much the algorithm goes wrong. So there is a huge dependency on the human who is executing this algorithm. And then the next one is outliers. When the data set has a large number of outliers, it can pretty much skew the clusters that are identified. So in order to solve this problem, what we need to do is we need to first remove the outliers from the data set before coming up with the clusters. And then last is scaling with the number of dimensions. The example that we went through had 2 dimensions. It had weight as well as height. The example that I have showed you on Title has 3 dimensions maximum. So as the number of dimensions increases, the complexity of K-means algorithm also increases and it slows down. So to solve this problem, what we can do is we can use techniques such as principal component analysis in order to reduce the number of dimensions before executing the K-means algorithm. So that's about the K-means algorithm. I hope you learned something new today. If you like this video and then if you enjoy similar content, please subscribe to my channel. Thank you. Bye.